This is Tyler Stewart, member of the DALA team, and this is my final technical presentation. For Sprint 3, here's my first child story. As a user, I want to be able to cancel transactions so I can leave a modal without saving the information. So kind of like Sprints 1 and 2, we have the same state diagram here, and we get to our decision point. The transaction is opened. Then we have the option to exit press or cancel click, and it'll close our modal. And over to the right is just an example of that with the cancel button and the exit button displayed. And we utilize HTML and CSS in the nav menu to create this. Next two are, as a user, I want to be able to enter a transaction withdrawal so that I can save my withdrawal to the system. As a user, I want to be able to enter a transaction deposit so that I can save my deposit to the system. So step one, we need to create our backend tables. And we kind of started this in Sprint 2, excuse me. So technology we're using for our table structure is Entity Framework, along with database migration. And we also are using a code-first approach. So what we do is we code our C# classes, and those translate to our, eventually get migrated to our backend database tables. We use this for our database version control, so we can roll back anytime we want or go forward. So as a quick review, here we have our transaction. Here we have, on our right, we have our UML diagram. So we have application user can have 0 to many transactions. And transactions, for our case, the difference is going to be the type is going to be withdrawal or deposit instead of transfer from our Sprint 2. And transfer from and to ID, one of these are going to be null depending on withdrawal or deposit. Over here is what the migration gets translated to in our database. So we have our users table, and it has 1 to many transactions, and the transactions use MoneyBox. So we have a foreign key to the user, and then we also have 2 foreign keys to our MoneyBox. So deposit will have a value in the to ID, and withdrawal will have a value in the from ID. So step 2, we need to get the information to the database. For data manipulation, we utilize the MVC framework design pattern. We will need to communicate a post request from the front end to the back end. Note, we will need to do a post call and a put call. I will explain in the next slide. So over to the right, we have our first post call. So as the user inputs the data and submits the page, this is going to be on the transaction view page. And it's going to send a command to the transaction controller. The transactions controller is going to see it's a post, and it's going to add the model. In return, that the model is added to our database. After it's added to the database, it returns a status of OK, and it refreshes the screen. Now, after this is returned, we immediately need to update our MoneyBox. So say we did deposit, we need to send a command to our MoneyBox controller and update our model. After we update our model, the data is updated in the database, and it also returns a status and refreshes the screen. Down to the bottom, we can kind of see how this goes. So we have our view and user adds transaction here. So the controller will be a transaction services, and this will update the model. The model then updates the database, and then returns notifies the controller that it's done, and then updates the view. This is our MVC structure for our design pattern. So here's 2 examples of the withdrawal and deposit of our screenshots. Our last Sprint 3 child story is, as a user, I want to see pay payments so that I can track the bill's history. So step 1, creating the backend tables. So the technology, again, we use is Entity Framework along with database migration, and we did a code-first approach. So we'll code our table that we need to store the payments, and we'll also translate that to our backend tables. So here's our UML diagram. So we needed to create a new table called Paid Bill to track the user paying their bills, and this has these public properties of ID of integer, bill ID of int to track the bill, the add payment method ID to track how they paid it as an integer 2, and the month as a string. These two are related to the add payment method ID and the MoneyBox ID. So these two are getting the IDs from these 2 different classes. When we run our migration, we end up with this entity diagram of the paid bill. So we have a primary key of ID, 2 foreign keys of bill ID, and a foreign key of add payment method ID, and then we have a column for the month, for which month the user paid. So step 2, getting data to the screen. So what we need to do is we need to load the screen with the payments that the user has paid. So as the user loads the bill page, it gets the ID from the query string that's passed over. So this is passed which bill they selected. It sends a GET request to the paid bill controller, and then it selects the payments. This will select the payments unique to that user. The data is retrieved from the database, and then the database returns JSON. So this JSON is returned to the controller, and then it refreshes the screen with that data. So going on to sprint 4, we continue the bill payments. So as a user, I want to have a list of payment methods at the top so that I can use them to pay my bills. So step 1, gather data. We need to make a GET request to the database using MVC architecture. So on the left here is kind of the GET request to get the payments. So as the bill page is loaded, we send a GET request to the add payment method controller. That controller goes to our model, and it retrieves from the database the user's payment methods. This returns an array of JSON back to the controller, and then in return loads our dropdown. And over to the right we can see our dropdown loaded. Next child story. As a user, I want to have a message if I paid a month's bill or not, so that I know which ones I need to pay. So step 1, refining data. Currently we have all the information on what months we have paid, but we do not have data on what we haven't. A human can easily parse this out, but we need to create a separate object with all months with a Boolean column indicating paid or not. So what we need to do is a simple algorithm to merge all months with paid months into an array of objects. So this object is defined in TypeScript to the left. So what we did is we created another TypeScript class, and this is represented in this UML diagram. So we created a month paid class. It has a public property of month string, a public property of paid in its Boolean type, and a public property amount in its a number type in TypeScript. So once we load that, data will now have a two-way binding to array in HTML and TypeScript file. So using an Angular repeat, like a for each, is ready to be populated into table. So we have two components. So what we did is, in the previous slide, we got our data, and now what we need to do is we need to load the data into this month paid object. So after we get our GET request, we load it here. Now we have two-way binding to the other file. So we have the TypeScript component file and HTML component file. And there's an object for the month paid, and it's binded from this file to this file. So any changes we make in the TypeScript component file gets reflected in the HTML component file. Same vice versa. If the user makes a change in the HTML component file on that object, it gets reflected in the TypeScript component. This keeps a two-way binding between these objects, and it's easier to maintain. So here's an example of the grid indicating now we have a paid and unpaid column regardless of the month. As a user, I want to have a button to pay bills so that my bills will get paid. So this one's pretty simple. As data is being populated from the previous child story, we will add an additional column for each element in the array. Using an Angular repeat, we can achieve this. So here's our column. So for each object in this month paid object, we just add a column for pay bills. And this pay bill will be linked to each element in the array. As a user, I want to click pay bill so that I'm keeping up to date on my payments. Step 1, getting information to the database. So as a user, as they click the button on the bill payments page, it sends a post request to the paid bill controller. The paid bill controller then adds the model to the paid bill model. That data is then inserted into our database. Then it returns a status back, and then now we just refresh the grid. Thank you very much. These have been all my child stories.